dipole in a uniform external magnetic field. This is the second part of the problem. In the last part we saw if the magnetic field is in this direction, dipole is at an angle theta and the magnetic moment of the dipole is m, then energy of the dipole equal to m minus mb cos theta, which you can well write it as minus m dot b. So suppose if there is a question like what is the work done in rotating a dipole from, let us say, 60 degree to the magnetic field to 30 degree to the magnetic field, what is the work done? So in this case what you do, and find out the initial energy. Initial energy in this case is in mb cos 60 degree minus mb cos 60 degree. So initial energy is cos 60 minus mb cos 60 degree is 1 by 2, and the configuration, the final configuration is final energy equal to minus mb cos 30 degree. So minus mb cos 30 degree is minus mb in cos 30 degree is root 3 by 2. Then the work done in this case is final energy minus initial energy. But here look for the sign. So the final energy is minus mb into root 3 by 2 minus of initial energy is minus mb by 2. So minus into minus plus. So if you take mb by 2 out, it is plus 1, or I'll do it step by step. So if I take mb out minus root 3 by 2 minus into plus 1 by 2. So if I take mb by 2 out, it is 1 minus root 3. The whole quantity in this case is a negative. So this negative means work done by the external force. Work done by the external force is negative, but work done by the dipole work done by the magnetic field on the dipole, work done by the magnetic field on the dipole is positive. Because it is positive, this work done happens to be negative means the energy of the system decreases, because this work done is the external work done. So the external work done, because usually the work done is calculated by finding the final energy minus initial energy. When the final energy is lesser than initial energy, the answer is negative. That means that the energy of the system decreases. Because energy of the system decreases, and work done by the system is positive, work done on the system by the external forces negative. Let's look at another case. Suppose there is a magnetic field in this direction. The dipole is at an angle 60 degree, and you are actually changing the system into like this way 120 degree with the magnetic field, or I will say 120 degree with the magnetic field. What is the work done in this case? In this case, initial energy equal to minus mb cos 60 degree. So it is minus mb by 2 is the initial energy. Final energy is u final equal to minus mb cos 120 degree. So the cos 120 degree minus mb cos of what you can write it as 90 plus 30 degree. 90 plus 30 degree is minus mb cos of 90 plus theta sin theta. So it is sin 30 degree, but it is in negative. So here it is cos of 90 degree, it is a first quadrant, hence cos becomes negative. So that negative and this negative becomes positive, mb by 2. You see the initial energy is minus mb by 2, the final energy is plus mb by 2. That means the energy of the system has increased. hence the work done by the external force, is actually equal to final energy minus initial energy. Final energy is plus mb by 2 minus of minus mb by 2. So it is mb by 2 plus mb by 2, hence the work done is plus mb. So work in this case, work done by the external force is positive, and work done by the system on the dipole, work done by the system in the sense both the magnetic field and this configuration is negative. So work done by the system is negative, but work done by the external force is positive. Because work done by the external force is positive, work is done on the system. Because work is done on the system means energy is given to the system. That is why the energy of the system has increased from minus mb to negative to positive.